Hey there, we're going to talk about absolute value today. Hopefully this is something that you remember and we can just kind of build on it. If not, we'll kind of step through it. The very first thing is, what is the absolute value? So you can see down below, we do have the equation. And remember, it looks like some bars holding it in there. And what that means is, let's say we had the absolute value of 5. That means we should be dealing with x could be 5 or x could be negative 5. All right, so that means if we don't know what it is, it could be 5 or it could be negative 5. So you see it starts to build this V shape as we look at it in 2 dimensions as we get away from just a single dimension. So we have a lot of stuff going on. We have an axis of symmetry, which is this line right down the middle. We have a vertex, which is the very bottom, right? This could be upside down, so it could be the very top. Right, so that's going to be our vertex. We start to talk about that as being H and K eventually in this lesson. But those are the vocab words that we'll use, right? Axis of symmetry, it makes it the middle. If you ever get completely confused, forget it's a V shape, remember you can always make a table out of it. So if I plug in, right, we had talked about 5 and negative 5, working a little bit backwards. But if I just had this equation, absolute value, and I plugged in negative 3, that would give me 3. And that's what's happening here. So absolute value of 2 is still going to be positive 2 because it is the distance from 0. All right, that was long-winded. That was enough of that. You probably fast forward by now. Okay. So what are we going to do with it? We're going to take a look at a function. So absolute value of x, right? So absolute value of negative 1 is 1, 0 is 0, 1 is 1, 2 is 2. Well, what if we did absolute value of x and then we did minus 4? So now we're just going to deal with y minus 4 and see what that would be. So this is now 1, right? Because I plugged in negative 1, I got 1, and then took 1 and I subtracted 4. So I'm at negative 3. 0 minus 4 is negative 4. 1 minus 4 is negative 3. And 2 minus 4 is negative 2. So let's start with the parent, right? The parent sits down right here. And what we're going to do is identify what's different about this one. And in this one, my kind of the middle, the starting point, right? Because we were at 0, 0, 1, 2, 3, 4. This one is 0, negative 4. But then I have that same V shape, right? So they're going to look exactly the same. That's what we call it a parent graph because they look similar to the parent. Okay, so we have the original one. This was y equals absolute value of x. And this is y equals the absolute value of x and then minus 4. So what really happened to it? It moved down 4. Okay, so this minus 4, it's outside the absolute value. So this is going to cause it to move down 4. That's not too bad. So what's going to happen if we do x plus 2? How's it different? Well, it's going to move up 2. Okay, so if we had the parent, and I'll switch color pens here, that means I go up 2, and then I put this one on here. So it's a vertical shift up 2, right? And that's how we talk about it. It's a vertical shift. Very academic in our language with it. We know it goes up 2, but it goes up 2, and moving up is moving vertically. So we get that kind of taken care of. So now that we know that, what can we say? Transformations of any kind. So if I change the value of k, all right, what's that do? This is going to move it up or down, right? Up if it's positive, down if it's negative. But what about the axis of symmetry? So if I go back and I take a look at this one here, and I put in my axis of symmetry, for the parent, it was this vertical line. Would it be different for the purple one? No. Okay, so do these transformations have an effect on the axis of symmetry? No. Okay, we're only moving up or down. Okay, so that won't change it. These are all going to be that vertical line. So remember, vertical, it must be x equals 0 for that axis of symmetry. All right, so we covered what happens in that vertical translation. Okay, so the next one, we have a couple of things we'll deal with. We have horizontal. So notice what's happening is we're putting a number plus or minus inside of the absolute value. So that's how we know it's going to move left or it's going to move right. But notice what happens. If it shows that it's going to be negative, it actually moves to the right. And if it shows that it's positive, it's going to move to the left. Right? So that whole idea is opposite. So this is what I normally talk to you guys about in class, is if it's inside, it's going to be left or right, but it's going to be opposite. Okay, now the reason being is if we go to solve it, we'd be solving x minus h, and we add it to the other side. So that's the reasoning on why it happens. But as far as just making these translations today, that's all we really need to know about it. All right, the next thing you need to know is if we're talking about a reflection, okay, if it's negative, that's the one that goes upside down, right? So we had alluded to that up above. Right? And then if we have a y-axis reflection, so if this happens, then our rule for left and right is kind of thrown out. Okay, so we'll probably not deal with this too much until we talk about domains anyway. The other thing we have to think about is if I multiply it by something. So if I multiply it by 5, right, because that's greater than 1, that's going to make this thing stretched. So that means I'm going to take this absolute value and it's going to be really tall V. Whereas if I multiply it by 1/5, so I can fill these in, and if we deal with it that way, that's going to make it really wide. Okay, so we try not to call this the slope, but it works like slope. Okay, for my first point and being consistent, right, this is a graphing pattern. So this would be up 5 and over 1. This would be up 1 and over 5 to find out those points. So that's our A value. And again, the language we're going to use is that it's been stretched vertically or that it's been compressed, right? Think of compressed as something is being squished down on it, so it's spreading out, right? Just like when you're little and you played with Play-Doh. You squished it and it spread out. All right, so we have these two ideas together. So the first thing we talked about was +3. Remember, that moved it up 3. So I'm looking for a graph that's been moved up 3. So A, no way, and C, no thank you. Okay. Now the other one, we didn't do a ton of examples. Actually, didn't do any yet. We just talked about it. If it says +2, remember plus, we think right. So this actually has to be left 2. So left 2, now my answer is D. Okay, because that's that inside part. It's going to be opposite. All right, let's try it out. So +2, we just said that's going to be left 2. So I go 1, 2. -4 is down 4. So I'll go down 1, 2, 3, 4. So that's my vertex. That's -2 with 4, because we could build these back and forth. That's also going to be the very middle of it. This is my axis of symmetry. X equals -2 if we needed it, right? These numbers repeat. And then there's no number in front of it, so it's like a 1. So I just use a normal V shape. Not going to get overly excited about that until we put some numbers in there. All right, let's try the second one. Go ahead and give it a pause if you want to and try it out. All right, welcome back. Let's see if you got the same thing I did. -5, so we're going to the right 5. 1, 2, 3, 4, 5. +1 is up 1. It is the normal graph. So my vertex point was 5, 1. The axis of symmetry, x equals 5. And then a normal 1 for the A value. So I'll just draw a normal V shape on there. All right, let's add the last part here is 1/2. Remember, 1/2 is less than 1, so that means it's getting squished just like the Play-Doh. So it does start at 0, 0 because there was nothing added inside or outside. So there's nothing to add on to the graph, so that makes it a little bit easier. And what's going to happen is I'm going to go up 1 and over 2, up 1 and over 2, and I do that left and right. Okay, but it's only going to be the right side that looks like it, because we know the left side is a -1/2 slope, but it's the absolute value, so we have to deal with it this way. Okay, so that means A and B here, they're both going to sit right on the origin. And in this first one, remember it's up 2 over 1, and its reflection. And that's all we really need for the graph. Okay, what about -2/3? Again, 0, 0 is my beginning point. I'm going to go down 2 and over 3, and its reflection. So down 2 and to the left 3. All right, I missed my point, but you get the idea. Okay, so here's what we're going to say. Right, I multiplied by 2. This made it tall, right? We stretched it just like that Play-Doh. Okay, so this is a vertical stretch of 2. If A is negative 2/3, this is a x-axis reflection. And since it's 2/3, this is a vertical compression of 2/3. Right? So these are our vocab items in this section. X-axis reflection, right? Because this is our x-axis, and normally it opens up. So this one was reflected over. Okay. So finally we can put it all together. So we know we're working left and right, up and down, and then also the A value. And that could do a couple different things for us. So without graphing it, don't graph it. What's the vertex and the axis of symmetry? So let's first think about what happens. So for x minus 2, where is it going? Okay, it says minus, so we're going right 2. So that means my vertex is going to be right 2, positive 2. The next thing that's going to happen is plus 4 is up 4. That means I would be up 4, so 2, 4 is my vertex. The axis of symmetry, x equals 2, right? That's literally the x value. And how is it transformed? Okay, so we've already started answering this question. We know that it's going to be right 2, it's going to be up 4, and what about multiplying by 3? Okay, so will that stretch it out or squish it? Right, you're going to stretch it out. It's a vertical stretch of 3. Okay, pretty good, pretty good. All right, let's work backwards. What's the equation of the graph? So let me get some of this mess out of the way here. I'm going to leave this negative 1, 4 on here because a negative 1, 1, 2, 3, 4. Right? So I must have left that from last time. So that's good. So that means inside. How do I get to the left 1? Well, it means I need a 1 on the inside. But for it to be negative, I have to use positive. For it to go up 4, I need to use positive 4. All right, this thing is right side up or upside down? Upside down. So I'm going to put a negative sign here, nice and bold. And if I go down 1, I go 1, 2, 3 to get to the next point. So it's down 1/3. Okay, so how do we describe it? We're going to go left 1, up 4. It's an x-axis reflection, and it's compressed by a factor of 1/3. Ooh, look at this one over here. It's very digitized. I don't even know if that's a word, but I just used it. Okay, so here we go. This is 0, so 1, 2. And it looks like down 1. So 2, negative 1 is my ordered pair. So x equals, leave a little space, x has to go with 2. And I know it's minus 1. That's the easy part. That one's true to what we see. The other one's opposite. So if I see positive 2, I'm going to use negative 2. It opens up. So I don't need a sign, but I'm going to remind myself that it's positive. And this time, if I go up 1, I need to go over 1, 2, 3, 4. Up 1 over 4 until I finally get to a nice point. All right, that's the whole thing. So we'll list some to work on here. What we'll do is we want to graph each equation. You know what? These look, yeah, I don't think we need all of these. So let's just pick a few of these. I'll get them highlighted. So it'll be highlighted in your notebook. Without graphing, identify a ton of information. So this section we are going to do all of. And being able to write that equation. So we're going to work a little bit backwards.